Good morning, class. How's everyone today? Good. Did you guys have a good weekend? Well, I did. I actually did a lot with my son. We kind of did a lot of things that are going to relate to today's topic, which is energy. I'm sure you guys used a lot of energy this weekend as well. He's a soccer player, so he used both potential and kinetic energy, and that's going to be our topic for today. Can anyone tell me any type of energy they think they used this weekend? All right, Zoe, go ahead and let me know what you used. All right, awesome, you went skating. Skating is very good. That's a good form of energy. Do you know if it was kinetic or potential? No, it's not potential, it is kinetic, but we'll get deeper into the lesson and we will discuss more about the differences in the actual meanings of energy, potential energy, and kinetic energy. By raise of hands, who knows what energy means? Okay, Jacob, tell me what your answer is. All right, so your answer is the ability to be able to do things. Well, that's how I would describe it, but there is a way that we describe it in science or define it in science. I'm going to write it up here on the board and make sure you have your graphic organizers out so that you all can take these notes. All right, energy, sorry, I'm just looking at my notes real quick, guys, just so I can make sure I give you the correct definition. Energy measures the ability leave my notes again, for things to change themselves energy to change themselves and or to cause things to change. All right, so that is the definition in science of energy. Energy measures the ability for things to change themselves or to cause things to change. Does everyone have that written down? All right, some examples of energy are temperature, speed, position, pressure, and even any physical variable that you have would be a form of energy. So anything that we do pretty much can have energy in it. Now, let's see. All right, before we end this chapter on energy, we are going to learn about several forms like I stated, but we're going to do potential and kinetic today. Potential energy is the energy of position. So that means anything that's level is at position and it's using potential energy. Potential energy, in other words, are things that are at a rest. So even when you're going up and down, you're using kinetic energy, but when you make that stop at the top or that stop at the bottom, it is considered potential energy. Potential energy also has a formula that we use to calculate. However, let me just go back a few steps and give you a few examples of potential energy in a little more detail. A car parked at the top of the hill is potential energy. So it's waiting to, the kinetic energy is waiting to be released. That would be the car going into drive and accelerating, and then we go into kinetic energy. How about a boulder sitting at the top of a mountain? A boulder at the top of the mountain, same concept as the car on the hill, it's going to have to go down in order to move into kinetic energy, but when it's positioned up top, it's considered potential energy. And our last one is water behind a dam. This is a little different than the top thing. Now we're behind something. So the dam is there and the water is just waiting to be released. So for instance, once the dam breaks, then it goes into kinetic energy. And once it stops again, if that ever stops, usually they don't, but if it ever stops, it's considered potential energy again. Are there any questions? Good. All right, so we're going to go over the formula for potential energy. Just so you guys know, energy is measured in joules. So anytime you are working on energy formulas, everything is going to always end up, the in joules. So on my paper here, we have an example, and potential energy is calculated as mgh. The unit we use for energy is joules, like I said. The m is for mass of the object, and it's usually measured in grams or kilograms. The g is for the acceleration of gravity, which we will always use 9.8 milliseconds squared. And the h is for height from the ground, is the height from the ground, and we measure that in meters. So we're going to do a quick problem on the board. I need everyone to pull out their calculators. All right? Okay. So now we're going to have, the problem would be the potential energy of a 95 kilogram rock at the top of a 45-meter cliff. Jack, I see you have your hand up. Do you have an answer for us? That is correct. 41,985 joules is the correct answer for that problem. Did everyone see how we calculated that? Yes? All right, good class we have here. Do we need to do another problem together? No? Are you guys sure? Okay, well, let's move on. I know I've touched on kinetic energy a little bit, but I want to tell you a little bit more about it. It is the energy of motion. If you haven't picked up already, as I was stating when I was giving you the examples for potential energy, they work together a lot. So kinetic energy is actually the movement in the process. So the car down, the boulder down, the dam forward. The water is your kinetic energy being used. The amount of kinetic energy an object has equals the amount of work the object is doing. As I said with the formula for potential energy, there's also a formula for kinetic energy. Any questions? All right, so some more examples of kinetic energy that we would be used to is a roller coaster. A roller coaster is a great example of kinetic energy. Can someone tell me what that, like how they can process kinetic energy in a roller coaster ride? Okay, Sam, I see your hand up. Can you answer that question for me? Exactly. So you have the roller coaster here. You have your little tracks with the people in it. And then as it goes up, we have kinetic energy. But down here, don't forget, we were at potential energy. We go up, we get here, and we're back at potential energy. We're back at a standstill. And then our little train, where we're all excited and going down, we get back here, we're back at PE, but here is our kinetic. So you have kinetic energy on both sides of the roller coaster. So from the beginning to the end, you experience both of those twice. Everybody understand that? All right, awesome. So we're just going to do a quick conversion or calculation of kinetic energy. Kinetic energy, let's get this fancy stuff off of here. All right, kinetic energy has a formula. It's 1/2 mv squared. The m is for mass and the v is for velocity. All right, so everybody have their calculators out again? Just reading my problem here. Here it is. A bicyclist is traveling at 11 milliseconds. The total mass of the cyclist and the bike is 74 kilograms. In this one, it's taking a little more time. So take your time, try to figure out the half part, because I know that could be a little complicated. Because that formula, you know, you have to break down. Sorry, I forgot to give you guys a formula. Oh my, or did I? I think I did. But we'll repeat it. Kinetic energy is half of mass and velocity. All right, Joy, I see you have an answer over there. All right, great job. It's 4,477. That is, and it's measured in joules. All right, so that is how we would measure. You did get the answer correctly. Did anybody need me to go over it? Because we do need to move on. No? No more questions? All right, you guys are an awesome class. I'm going to give you out a sheet. We're going to do a lab on Energy Skate Park. So we're going to go online, and there's like a simulation of a skate park and a little man, if you can see it. I know it's kind of small from up here. All right, and then we're gonna go in the lab. You're gonna position your little man at the top, and you're gonna put everything in slow motion. You'll actually see how the kinetic energy and the potential energy works with the graph on the side. You'll actually see how it goes up and down. All right, any questions? You guys sure? All right, well, if you come up with any questions while we're in the lab, please be sure to let me know and I'll be happy to help you. All right, pack your things up and let's go.